Have you wanted to get into building mobile apps that use AI? Not sure which language to use? Today, we're going to use Tauri, which is a multi-platform app framework written in Rust. Using the basic tool that we created in the first episode, we're going to create a mobile app that works on my Android phone. There'll be a few hiccups again, and we'll get into it, but we will end up with a working mobile chatbot app in this episode. So let's go ahead and dig in.
We have our agent just telling us the time, but it's doing something. Now let's try and give it an interface that allows people to chat with the agent. We're going to use Tauri, which is an application framework written in Rust. It's open source. It's run by a lot of great people who've put in a lot of good work over the years. And now we're at version 2, which does support mobile. It doesn't create native mobile apps, but what it does is it uses WebView. So instead of using the native UI, it'll use a packaged version of WebKit so that we can use one bit of source code to render on different devices. You can build applications that will run on desktop, they will run on Mac, they will run on mobile, Android and iOS. I'm not going to be able to build an app for iOS in this tutorial. I will need a Mac for that, and I don't have one currently. But we can build the Android version. We're going to get it to come up on my phone, which is currently dormant here. Very soon, we'll have an actual mobile app. We're going to need to use Tauri too. Now let's have a look at documentation, and let's see how we can get started. This will tell you a bit more about it, but we actually just want to start quickly. So we need to make sure we have the prerequisites in order to render and build this application. Like I said, it's WebKit. I'm actually on Arch. I would use this and it will install all the dependencies that I have, native dependencies, so that I can build my app. For Android, we're going to need a little bit more than this, but this is the basics to get a desktop app working. So I've already done this, but if you need to do this, go ahead before you try and build anything. Windows, you can actually cross-compile for Windows from Linux. We're not going to do that right now either. You also need Rust, obviously. Node for the front end. And this is how to configure it for mobile targets. Like I said, you can configure it for Android. You will need Java. You will also need Android SDK. So if you go and download Android Studio and install the SDK and the NDK and install Java, then you're basically there. But I've already done that. I will need to set these environment variables so that it knows where your Android development kits are, and we'll do that in a bit. But first of all, we actually just want to scaffold a project. So we go to the guides, create a project. It says here, works with virtually any front-end framework. There is actually a scaffold CLI. So we're going to go ahead and move the logic that we have into a newly scaffolded Tauri app because the scaffold tool is great and we don't want to write all of that code ourselves. We're first going to move up a folder. If we did it in the one that we had, it would complicate things because of the cargo workspace that we already had set up. So we're going to go and get the scaffolding command. We've already installed create Tauri app. We're going to use the cargo version. It's going to walk us through things. We're going to call it agent conversation. Yep, why not? We're going to use TypeScript and JavaScript for the front end. We're going to use PNPM as package manager. We're going to use Preact. There we go. It's that simple. It tells you how to run it. You can run the desktop development with Tauri Dev. We can run the Android development with Tauri Android Dev. Although we are going to have to first run cargo Tauri Android init. We're going to want to check that we have a device, which we do. So let's just add this as a workspace. And this is going to help us to just move things over. As you can see, slightly different name. We're going to need to copy over these dependencies. And this time we need to move them into the source Tauri manifest. It already had CERD.json. That's great. We'll keep the newer version. Already has CERD with more limited features than what we added. So yeah, but it's probably all we're going to need. So we can remove that. That's all happy. And you see it's created a library here with the name, with the lib suffix. And it's got a crate type. We won't go into that right now. That's beyond the scope of this. And it's created a Tauri app in the source folder where we have a binary, which is just going to run our library. It's building a runtime, basically, which is going to be our asynchronous runtime for our app, but it's also going to have all the framework goodies in there. It's configured so that it already has this plugin, which allows you to open links, I think, and it's going to invoke the handler for a command. This is a command up here. It's annotated with this macro, Tauri command, which is going to turn this basic function into something that Tauri can understand as a way of providing an interface to the app that we're building. Currently, it's just doing a basic greet function. We're going to replace this with the logic from our existing project. So we can actually just copy over tool, and we can copy over this logic here and the imports. Put that in our lib at the top. And then we're going to take this macro here and we're just going to put it on our function. We're going to delete this and we're going to change the name of the command to chat with agent. And all that's done is it's replaced the boilerplate with something that's useful for us in our app. And this is going to be something that we can call from the front end. You could think of it as the contract between the backend and the front end is defined in terms of commands, and there is a JavaScript library that will allow you to invoke those commands from JavaScript. There is inter-process communication, which is an event-driven system, which will allow you to run Rust code from JavaScript just by sending events. So this invoke handler here, if you wanted to add more commands, obviously just add them to this vector here. It's going to generate handlers for them. It's going to run with the generated context, which we won't go into right now. And then it's going to fail if that doesn't happen, because this is basically starting the runtime. And if it doesn't start the runtime, we want the application to fail. So this is what's happening in our run handler, which is being run in the binary. And we still have our module here working just as it was. We can actually get rid of the warning because we're not actually going to use the arguments. It's only ever going to give us the time. And now that we've done that, we can move forward to looking at the front end. We're probably going to want to just run the app first. Let's try out those commands. So if we run Tauri dev, okay, we already failed. We didn't install our package.json. So we used pm as the runner. So we're going to install. That installs all the basic stuff that was scaffolded, as well as that Tauri apps API, which is going to be the SDK for dispatching events to our backend, as well as a load of other things. So we should now be able to do run dev, which is just going to run the UI. If we copy this over, now be able to look at that in the web browser. Okay, that's cool, but it's not that cool. I would rather run it on my phone. Before we go ahead, we're going to make sure that we have Android SDK environment variable set and the NDK one. Looks like I've done that before. And I also have to set some OpenSSL ones, but that's just because I'm on Arch. You probably won't have to do that. There we go. And I believe I just need to set the SDK as well. We should be good to go now. We're going to run Tauri Android dev. And it's still, you can see it's still running our web server, except it's got a different IP address. Basically, our device is going to stream from the web server in order to render the UI in dev mode. When you build it, actually put it on your phone, it will actually build the full UI, but that would be too slow in development. So what we've got is this web server running. You can see it's compiled. It's found a load of libraries. This is the Android build process. Looks a little bit different, but the source Tauri gen folder, after we ran that Android init command, and now actually has pretty much a full Android app in here, and it's going to run the Gradle build process there. But thankfully, Tauri does actually shield us from a lot of this stuff. We're going to be going deeper into Android and Kotlin later on the channel. But for now, we're going to let Tauri pamper us for a bit. Here we go. we have the mobile version. As you can see, it looks identical. Now, if we want, we could actually just package this as an APK and run it built on our phone. The UI is not native, it's still WebView. So for certain apps that need high performance, I wouldn't recommend this. For a lot of apps, this could be all you need. I don't want to make this all about UI. I actually used V0 to generate a front page for me. I'm just going to paste in for the moment, and then we're going to adapt that. If you want to prompt and get a similar UI, you might have to patch it together a little bit and make some edits like I did, but this is the prompt that should get you pretty close. And what I'm going to do is just copy it, and I'm going to put it into V0, which is pretty good tool for building UI components, especially in React. Other GenUI tools are available, obviously, but this one seems to work pretty good. And then what you get back, you should be able to patch into your app.tsx and maybe wire it up like I did in the video with the Tauri API SDK. I'm going to use auto import to add all missing imports. And we have a message type here, which I haven't yet defined. So we're going to have a role, which could be a user, an assistant, or system role, the content, the string, timestamp, which is date, and tool calls. This will just be a way of interacting with our agents from the front end, and it's going to return agent chunks. We've got some local state, we've got some use effect here. So this is going to set a lifecycle hook on the component, which is going to listen for our agent chunks, and this is going to be the event from the backend over Tauri's inter-process communication. It's basically an event bus that's going to allow us to listen to that from the front end. We're just going to process the chunks, and then we're going to add it to the chat. This is the markup that we copied from V0. Because it was Tailwind, we do have to add Tailwind. I'm going to do that the lazy way here. I'm just going to add it to the index. You might want to set it up properly in your repository. Now, we should be able to run Tauri Android Dev. And here we go. We have the mobile version.
If you've been enjoying this series and would like to help me share it with more people, just give me a quick like and a subscribe. Hell no. Thank you.
So I made a couple of little fixes to the UI. The font was the wrong color, but you can see how it's working so far. It's just going to set the state of this text box. And when we press the send button on the message, it's actually going to create this loading, assistant thinking, and it's going to say what's the current time on the speech bubble on the right, which is me, and my assistant is thinking. So it's pretty good so far for something that we just generated, the front end at least. So now we need to wire this up so that the assistant actually sends something back. Because currently it's not doing very much. It's setting up a listener, it's listening for agent chunks. We're not actually sending anything back. We're not actually in contact with our agent at the moment. Now we're back in our lib file, and we're going to adapt this so that it can hook into the app context, the Tauri app context. So we're going to want an app handle here. And just by virtue of this function now being a command, it can actually get access to this automatically as the second parameter of this function. You see, it's not complaining. It's just saying it's unused, but it's not saying it doesn't exist. Well, this is a strongly typed language, so if it wasn't there, it would be complaining a lot more. So now that we've got that, we can actually emit events using the app handle, because the framework has an event bus, and now that we have a hook into the app, we can update what happens when we get a response from our prompting of our agent. So we're going to change this response part here, and we're going to say, first of all, we need to send something back. Let's have a look at what we're expecting, our listener is expecting. So we're going to want to emit events using our app handle, but first we need a type to use for that. So we're going to copy the type that we had in the front end. It's slightly stronger typed. It's going to need to be serializable because we're sending it in message form. and it needs to be understood on the other end. It's going to be pretty much the same as the app version, except this is going to be a JSON value or an option of a JSON value. Working with this API of rig, when we await the agent prompt and we get a response, it's going to stream the response in chunks. So now we have the correct type. We can actually just define our agent chunk as the delta is some response, instead of just returning it as the result. Then we can do app handle, and we can emit our agent chunk. And we're just going to unwrap this error for now. It's actually asynchronous though. Oh no, that's not why it's complaining. It's complaining because emitter, again, the extension trait Tauri emitter is not in scope. And that's going to allow us to emit events. Similarly, for the error branch, we're going to print out the error, and then we're going to return as a different kind of chunk that's just going to be a formatted error string. And this time we'll handle the error and print it out. So we need to actually change the return type, because we're actually no longer going to be returning a string, because we're actually emitting it on the event bus instead. We're going to have void there as well. We'll just return void. And that was already void, so we'll just return that. And we're compiling again. So chat with agent now is wired up to return the data to the front end. And how do we know that we're sending from the front end to the back end? With the JavaScript API on the front end. So actually, if we go back to the event handler on the front end, which is bound to our button, we can have a look down here. Handle key press will also do it, but when we click on the button, it's going to run this function handle send message. And what's that going to do? It's going to trim our text. It's going to create a new message. So this is the message coming from front end to back. The message is what we've just typed in and pressed enter or click the send button. We're going to set it in state. So this is just going to update our UI and set the assistant message. So it's going to be a new response from them. And then we're going to run this bit of magic, await invoke, which comes from, again, the Tauri apps API. And what does it say? It sends a message to the backend. Pretty straightforward documentation. Chat with agent. This is the name of our function. So seeing as we assigned it as a Tauri command already in lib here, it's automatically with this macro allowed us to send an event with a payload, which is a string message here. So we're going to send our message text, and then it's going to send it to the LLM. It's going to process via the streaming API of rig, and then it's going to send it back to our listener, which we set up here. So now I'm going to ask the time. This time it's thinking, and we're waiting for the response. And it didn't work, which is going to happen sometimes. It seems like a great opportunity to show you my logging and debug setup. There is a Tauri log plugin which works for all platforms. Seeing as we're using Android, we can actually use a crate called Android Logger. We're going to initialize it at the top here, you can see, and I've set a tag called agent conversation. It can be whatever you want, which will just help me filter out the Android logs, because we're going to be getting the logs through ADB logcat. This means that we can't easily print and log and see it in the console as we usually would with a Rust app. We're also going to need to manually pass our .env file so that we can pass environment variables like the OpenAI API key, which was the thing that was stopping this app from working. When you build an Android app through Tauri, it won't have access to your normal file system. So you have to bundle it in some way. This is just one way of doing it. So now all I have to do is in my console run ADB logcat, and then to filter it, pipe that into a grep command, passing the string that I set here, the tag. And then if you want to be super specific, just to get logs from your library that you're working in, you can add that on as well and play around with this to get different levels of filtering. And what you end up with is very specific logs, as you might be used to if you were logging in a normal Rust app. I also thought it's a good time to show you how to debug the front end, seeing as it's running on the mobile, and as I said, it's streaming from a web server on your local host. If you want to hook into the web view, you can actually use Chrome. Go to Chrome, inspect devices, you can click inspect, and it will actually come up with Chrome DevTools for your web view. So you can actually inspect the UI, you can adjust styles in here, everything that you could usually do in Chrome DevTools, which is pretty useful when you're debugging the UI. And we're back. Now that we've fixed the issue with the environment variable not being set, and we used the Android logger to figure that out, the app works. I'll give you a little demo. Now when we ask for the time and we press send, it's going to think a little bit and then it's going to interact with the agent and it's going to send back the response.
And that's it for now. We managed to get our mobile app working in the end with the environment variable set. Join me next time when we're going to rig this up to a MCP server to make some external API calls using our agent, using the same mobile app that we've just built. Until then, happy building. Check out the links in the description if you need any help on this, and give me a comment if you have any issues with it that you might need help to work out.